So, welcome everyone to this training. The Royal Grand Engineering Trainees, REnT, and Nigerian Society of Engineers welcomes you to this training session on ProtaStructure. Today is the day two of the 1 month free engineering trainings that is organized by REnT in partnership with Nigerian Society of Engineers Ikeja branch in ProtaStructure. So we welcome you all to this day too. So today we are going to be talking about walls, creation, and properties. We are basically going to be covering the modeling aspects of design using ProtaStructure. So that means that we are going to be creating all the members that are used for structural design. So here we are going to be talking about walls, creation, properties, and wall model types. Then we are going to talk about beams, creation and properties, then slab creation and different ways that we can explore the slab functions. Then we are going to talk about the loadings, how to load your structure or your building. Then we now move to the building setups, that is story settings and all that. And then we now have some review functions. So now that should be that. So let's jump back straight to our software. But before we do that, let's have a review on our learning objectives. So at the end of this session, students should be able to model RC shear walls, model different types of RC beams, model slab and explore its properties, create walls on beams, insert, generate, and edit stories. So that is that for our learning objectives. So let's jump straight into Prota structure. So we are right here on Prota structure. What you are looking at in your screen is um the DXF file that we are supposed to use for our assignments. I've just completed the modeling and design um, of that building. It's actually a two-story building design. You can see we have our first story in this region, then second story, and then we have our roof level. So can you see that? So that is that. So if I go to the um, visual interrogation tab to check for the design status, and say okay, you are going to find out that the whole of the structure is showing green, which simply means that our building has now successfully passed the design. You can observe at the left side of your modeling screen the design status of that building, where green means okay, the members are okay, and red means failure. So we have expired analysis and warning as well, and then this blue and white that says do not design and not design respectively. So that is that. So you are going to notice additionally here this cantilever beam is also failing. That is showing red, which simply means that this cantilever beam over here has failed. Now I purposely left that to be failing. I intentionally left that so that I can be able to show you what it will look like when a certain member is failing. So can you see that now? So we also have this white color showing that is not designed according to our design status. So I did not perform the slab design so that I can show you as well what it will look like when a member is not designed. So additionally, you can observe the part footing details. So we have the part foundation um, footing that is supporting the building, as you can see now. So you can also observe our shear walls has now been successfully designed as they are showing green light, green colors. So here we have our, let's go to our plan view, and at the story level, so this is the story 00 level, this is basically the foundation level, and this is our footing details, our part footing, part foundation, footings and columns. So if I zoom in, you are going to see the column information. Okay, someone said you can't see my screen. So I believe the screen is actually showing very perfectly. So just try and log out and log in again. So here we have our column information axial load comparison with our dead load NGX notional dead load on X direction and difference combination as well. So you can see the different values of that. So we are going to be covering all these in our training so that by the time we have now finished our 1 month training or our training for this week, so we can now successfully be confident that we now know how to model, analyze, and design a building, at least a two-story building. So we can be confident on that. And that is basically what we are all about in REnT. So this is basically that about that. So without wasting much of our time, let's jump back straight to what we have today. So let me close this project. To do that, close a project without actually shutting down your software, what you can simply do is go to your building setup tab and you're going to find this option here that says close project. Just click on that once, and then we have now closed that project. So now let's jump back to what we have. So in our last class, what we did was to create axis and then columns. That is basically where we stopped. We have treated creating and modeling axis, and we have also treated how to create your RC columns. So let me go to the 3D view so that you can see where we are at now. So this is a different project from the one that we are doing before. So I personally wanted to use this project to teach that. So um, the knowledge you are going to get from this is going to be enough for you to even do your assignments or work on a different project. So I'm going to be using this project for our tutorial sake, for the teaching sake. So let's get to that. So many of I've been getting complaints that many of us are now using 2018 version of the software. So the 2018 version of ProtaStructure is a little bit, in fact, it's very different from the 2022 version upwards. I will advise you to upgrade to the 2022 version upwards so that you can be able to be following what you are doing very well. The reason is because there are many features on the 2022 software 2022 version upwards that you cannot find in the 2018 version. So that is that. But nevertheless, you can still use the 2018 version to perform your analysis and design successfully. So let's now begin our class. So, but before we jump straight into what we have, I want to show you us something that is going to be very useful for us in our design. That is how to change the cross section or the section property of your columns. So as you can see here, we have this one column 14 with the dimension 250 by 250. So assuming we wanted to use a circular cross-sectional column. So what you can simply do is select the column, right click and then say properties. Take the properties of that column and then come to this icon on your um column properties dialog. There is this icon that says section manager. Yeah, just click on it and then the section manager tab is going to show. So here we are going to find a different section of your concrete members, and when I click on the drop down we are going to find we have the option to change that to steel as well. This is different steel members. So let's go back to our concrete and we have different sections here. We have the circular section, the cross section, we have your T section, I section or H section, and then the hollow circular section, and then the L-shaped column. So let's say the circular section, then we have the option to choose the to select the diameter. We can do that in our properties dialog if we want. So here shows you just like a preview of that of the section you have just chosen. So can everyone still see my screen? Because I think I'm noticing some defaults.
Okay.
All right.
Yeah, we can see it. Yeah.
Very good. So when we have now successfully selected the section we want, the diameter, I mean the circular section, for instance, just say okay. When you have done that, you're going to have the circular section there. So you have the option to change the diameter of the column if we want, but let's leave it as 400 millimeter for now. Now say update. Now you are going to notice that once I click update, the square section is going to change to the circular section. Everything is now. So this is exactly what we have done. So now let's do the same for this column as well, in case if you didn't get that. Select a column, go to the properties, and then click on the section manager icon. Select your circular section. You can select the cross section as well. Here you are going to find the properties of the dimension, and here you are going to also find the preview of that with the letters indicating which side of the column belongs to which letter. Can you understand that? So let's continue. So let's choose the circular section and then say okay, and now say update so that it can update there in real time. Now close the properties dialog. So now let's go to our 3D view so that you can see what you have now successfully created. So let's pan that just like so. So this is our circular section. Can you see that? It's actually looking very exquisite. So without any further ado, let's jump straight into what we have for today. So um the first thing on our agenda today is walls creation, properties, and our wall model types. So now to create your walls, let's go back to our software ProtaStructure. So to create your walls, simply go to your modeling tab. You are in the building setup tab. Click on that modeling tab, and over here in your RC section, RC member section, you are going to find the wall to click on that once, and then wait a little bit. You are going to get your properties dialog. Now to create your wall, you have to specify a first point of your wall insertion and then specify a second point of wall insertion. Now to do that, simply specify your first point of insertion and then a second point of insertion. So we have now successfully created this wall. Go to the 3D view to view that. Have you seen how it looks? So let's continue exploring that. So please note that you cannot create your walls at a place where you don't have intersection of axes. So your walls, or else you're going to get that warning. Cannot find a common axis for the elements. Just click OK to get rid of that. So you can only create your walls at you can only insert your walls at axis and intersection points, just like so. So the 111 here, 3750 by 250 is simply the label of the wall. So the 111 is simply the label, which means story 111, and we have here the dimensions of the wall, 250 by 3750. So in your column properties dialog, we have the B as 250. B simply means the width of your wall, that is breadth, which is B. It simply means the width of your wall, that is the distance from here to this place. And additionally, we have your E, which simply means your eccentricity, that is your eccentricity distance. We have talked about eccentricity when we talked about columns modeling and creation. So, and now we have extension I and then we have extension J. So this extension I and J is used to lengthen the wall by a small distance. So it's basically for lengthening the wall at a small distance. So when I created the wall, you notice that I actually created from this axis insertion points, but you are going to notice a small lengthening of the wall from this place to that and so that is basically your extension I and your extension J. So the I end is the left side of your horizontal members. So this side, the left side, when you create a horizontal member, just like so, so the left side of it is your I end, and the right side of it is your J end. So the extension I is the extension at the left end, and the extension J is the extension at the right end. You can see that extension I, and then you have extension J. So this extension I and J are the value of your extension I and J should be kept minimal. So I don't advise you to leave your extension I and J to be going up as much as 500, 300, and all of that. So because this additional extension I and J is not designed to support any members, so leave it as minimal. So the maximum you can leave that is your should be half of the width of the wall. So you can see we have 250 here, and the extension I and J is 125. That is the maximum your extension I and J can be, the half of the width of your wall. Yes. So if we create another horizontal wall or horizontal member, so the left side is our extension I and the right side is our extension J. So if I should change this to 300, for instance, the extension I to 300, and then say update, you are going to notice that this wall actually extended by a little bit, by some distance towards the left side. So that is your left side, your left end of your wall, which is your extension, which is your I end. And here we have the right side as well. So let's change that back to 125. So and say update. So we have that just like so. So now let's create a vertical wall. To create a vertical wall, very simple. Select an axis intersection, first point of placement, and then select your second point of placement. So now when you have now created a vertical wall, your extension I is the bottom end of your vertical wall or your vertical member. Your I end is the bottom end of your vertical member, and your J end is the top end of your vertical member. Yeah, as simple as that. So your I end is the um bottom, the left side of your horizontal member or the bottom part of your vertical member, while your J end is the right side of your horizontal member or the upper end of your vertical member. So this is our shear wall properties dialog. So we have talked about the label, and we have talked about the length of story. That is basically one. The length of story that wall is going to be spanning is one. Here we have the label. The B here is the width of your the B here, we have the width of your wall, and E is your eccentricity. So what we have here is exactly what I have just finished explaining. So we have a preview of your wall. We have here your extension I, and then we have your extension J. Then we have your eccentricity. We have your breadth, that is your width of your wall, which is B as well. So here we have your um the level of the wall and the dimension of the wall as well. So here we have your extension I and J, which is exactly what I have just explained. So shear wall requires two insertion points called the I and J. So the I is the left end of the horizontal wall or the bottom end of your vertical wall. So the J is the right end of your horizontal wall or the upper end of the vertical wall. So basically this I and J is a function that ProtaStructure uses to mark different ends of your members to denote them, and it also helps that in analysis also. So here we have your B is your width, and E is the eccentricity, which should be equal to or less than the half of your width, half of B over 2. So you could understand this formula very well. I believe that. So extension I and J is a minimum extension to lengthen the wall. The extension I and J should be kept minimal and less than the width of the wall, as the extension does not carry or bear any loads. That is basically what I've just explained. So your extension I and J should always be kept minimal. So without wasting much of our time, let's jump back straight into ProtaStructure. So let's now delete these walls, and now let's now model our wall perfectly in the place where we would want that. So we have now talked about the first uh, options we have here in our properties dialog. Now we also have top I and then J. So this C4 B4 that we have here simply means the axis of intersection where our walls have been placed, or where our vertical horizontal members have been now placed. So let's go to the drop. So at the drop here, we have this option that says insert column drop panel. So a column drop panel is is a structural member or a structural element that is added to the column to help support the slab. It is usually used where we have flat slab. So that is a slab that is not supported by beams. So when you have a flat slab, you usually insert a column drop to the columns that will be supporting the slab in order to discourage punching shear force failures due to your punching shear force. So we also have the option to add your column drop panel in your walls when we are modeling our walls. So here we have the 3D option. So the plane options here, plane top and bottom options, are used to adjust the elevation of the wall. So leave that as default, don't insert anything here. Then you have the delta Z, I top, delta Z, I bottom, and J top and bottom as well. So this delta Z options is used to adjust the 3D height and offset of the wall. So by default, it follows the story height 1. I recommend you to leave it and do not alter any changes for now. So when we are going to be going further in most of our advanced class, we are going to be explaining all of this one after the other. And here we have the support type. Leave that as default as well. Now, our wall model types option. So here we have the option to set the wall model types. So we have the default option. We have your mid-pier wall, FE shear wall, basement and retrofit shear wall, and retrofit wall mid-pier as well. So the mid-pier wall is basically your reinforced concrete wall that is usually used where we have our lift um, region or your elevator shaft. So that structural element that is created around your elevator shaft is actually made of reinforced concrete walls. So they are not your usually your traditional masonry walls. So they are actually made of reinforced concrete walls. So when you are designing for that, you choose the mid-pier wall. So and here we have your basement wall. This basement wall, you choose this option if the wall you are designing is going to be supporting lateral earth pressures. That is, if you are designing for a retaining wall. Now, a retaining wall is a wall used to support lateral earth pressures, maybe active and passive earth pressures from the soil, and then your surcharge and all that. So you select this basement wall if you are designing for a retaining wall, and when you click on default, by default it sets itself to your mid-pier wall. So you can choose um, to select the mid-pier wall, or you can leave it as default. So by default, when you leave it as default, it automatically sets to the mid-pier wall. So let's leave it as that for now. So now let's model our wall. So simply go to your axis intersection. This is where we want to have our wall. Click on that place and then specify your second point. Let's add another wall here, just like so. And then let's now create our vertical walls, just like so. And now let's create our vertical walls again, just like so. So let's change the width of the wall to 300, and let's change the extension to 150, extension I and J to 150 as well, and then say update so that you can have that just like so. So now let's say escape. Let's select this one and do the same thing for that. Say update. So I've finished doing that just now. Say update and then say close. So now let's go to our 3D view so that we can see what you have now successfully created. So this region is where we are going to be having our, we are going to be assuming our elevator shaft or lift region. So that is that. You can see how we have now successfully done that. So that is all about our wall creation and our wall properties. So this one is still saying 250. So let's change that to 300. So we have done that. So the next thing in our agenda is our beams creation. So beams creation and our beams properties. So let's jump back to our ProtaStructure software. So now to create your beam, simply go to your modeling tab and at your reinforced concrete members section, we have your beam tool here. So simply click on your beam tool and your beam properties dialog is going to appear as you would expect. So here we have the label, your 1B1, and the type of beam, leave that as normal beam. So here we have your B, which is your, which is the width of your beam. So it is 250, and here we have H is the depth of your beam. The depth of your beam is usually 450, 300, depending as the case may be. So let's leave it as 500 for now. So we have the option to change it to 450. So let's change that to 450 and the width of our beam to be 250. So that is basically that about our beams creation, about our beam properties dialog. It is very similar to our walls creation or wall modeling. The same way we do that, they are very similar. So now to create your beam, simply hover at a region where you have a column or your axis intersection. So when you hover at that place, you are going to see this snapping that says column insertion point, or if you hover a little bit, you are going to see the axis intersection point as well. So you have the option to either place at your column insertion point or your axis insertion point. So it's basically the same thing. So, but in my case, let's say I always prefer to go with the column insertion point. When you click that, you're going to get this rubber band, um, just like as you would expect. Now, when you have gotten that, place at another insertion point, just like so. So you are going to get that rubber band again. That simply means you can continue creating your beams just like so. Continue doing that. Continue doing that until you get to the last one. So when you now finally get to the last one, column insertion point, then if you want to end this beam creation um, activity, just right click and then you have that just like so. So here we have our extension I and our extension J. So that is basically what I've been explaining. So the I is the left end of your horizontal beams and J is the right end of your horizontal beams as well. So here we have our beam properties dialog. So we have talked about the beam properties dialog, and E here is your eccentricity. So beam, similar to wall, requires two insertion points called the I and J. So the I is the left end of the horizontal or the bottom end of the vertical beam, and J is the right end of the horizontal beam or the upper end of your vertical beam. So model the supporting members first, like your columns or walls first before beams. Each beam must be unique between supports. That is, single beam should not cross column points. That is self-explanatory. So you ought to model your supporting members like your beams and walls and all that before creating your, like your columns and walls before now modeling your beams. So let's go back to our ProtaStructure. So continue placing that. So you can alternatively click on the first column and then go straight and click on the last placement point. So what is going to happen is that you are going to have beams that the beams are going to break up at different column insertion points. So you can notice that you have different beams here, one, two, three, actually four beams here. So when you click on your first point of insertion and then click on the last point of insertion, you are going to have beams placed at different column insertion points. So click there to place this one and then click this one as well. Press escape key. Now let's create this one as well, all the way down to this place. Escape. Create this one all the way down to this place. Escape. Now create this one all the way down to this place. Now create this one as well all the way down to this place. Escape. So alternatively you can also draw a window selection to insert your beams. So when you draw a window selection just like this, you are going to have beams placed at regions where we have your column or axis insertion points. So when I draw a windows just like this and then click there to release that, so automatically we now have beams placed at these regions. So let's continue drawing that and placing that faster. So please note that when you are using this method to insert your beams, so additional beams are not going to be placed where we already have beams created. So and the additional beams are not going to be placed on top of walls. You cannot do that because walls are already your self-supporting members. So you can only place your beams where the beams can only be placed where beams have not been created already. So this is what we have now successfully done. So now let's create a diagonal beam. To do that, I can just click on your column insertion point here. Make sure you have the column insertion point and then go all the way to this side, to this other side. So this is basically what you have. So we have now successfully done that. So let's go to our 3D view to see what we have. So this is what we have in our 3D view. Let's go back to our story plan view. So let's go to our beam. When we come back to our beam, you are going to notice that the properties of the beam we selected have just changed. So let's take the properties of this beam. So select that beam, right click and say properties, or go to your properties, to your beam tab, and then go to properties so that you can have the same properties of this particular beam. So now let's create a curved beam. So to create a curved beam, simply go to the curved beam insertion option and make sure you check that. So make sure you check this option that says curved beam insertion. So now click on your first point of placement, column insertion point, and now select a second point of placement. When you do that, you are going to get this rubber band arrow. So now you have to enter a radius of curvature. That is the radius at which your beam is going to be curving. That is called radius of curvature. So to do that, simply press your Shift plus F2 key on your keyboard to now input a radius of curvature. So you have the option to enter in the desired radius of curvature, but in my case, let me say 800 millimeters and then say enter. So when I've done that, this is what I'm going to get. So additionally, let me create another curved beam here. So click on your first point of insertion, then second point of insertion. You are going to get this. Now Shift plus F2 key on my keyboard and now input the radius plus the radius of curvature, 800 millimeter, and say enter. So now let's go to our 3D view to see what we have now successfully created. So this is what we have in our 3D view. Can you see it now? It's looking very actually very exquisite. So let's now model some cantilever beams. Now to create your cantilever beams, go to your beam tool. But before we do that, let's first of all offset this axis. Let's offset this axis where we are going to be placing our cantilever beams. So I want to place cantilever beams at this region. So to do that, remember we can only place our beams where we have axis. So let's first of all offset this axis. Simply left click to select the axis, right click and say offset. I hope you still remember that. Now say Shift plus F2 key on your keyboard, 1500 millimeters, and then say enter. So in case you are just joining us, this axis offset um, and axis modification have been treated in our previous class. So simply visit the Royal Grand Engineering Trainings YouTube channel so that you can be able to access the recorded videos. Okay, that is that. So now go to your beam tool or simply select a beam, right click and say properties so that you can take the properties of this beam. Now it's still 250 by 450. Now click on your column insertion point and now click at this axis insertion point. So we have now successfully created our first. So we have now successfully created our first beam, cantilever beam. So you are going to notice this cantilever marking, this triangle that appeared here. So this is actually your cantilever marking. You can see how it's appeared. So this is showing that this end is a free end. So where you have this cantilever marking, it shows that that end where you have the cantilever marking is your free end, the unsupported end. So you can notice that the cantilever marking is also looking like an arrow that is pointing towards the left direction. So this cantilever marking usually points to the direction where we have our support. So this is our column that is supporting this particular beam, and your cantilever marking pointing to the end where you have your support. So now let's continue creating that. Take the properties of this particular beam, and now let's go from here to here, press escape, go from here to here, press escape on your keyboard again, from here to here, press escape from here to here. You can see the way I'm doing it very slowly. So that makes a lot of sense. So now let's go back to our 3D view so that you can see what you have now successfully created. So this is what our cantilever beam looks like. Can you see that? It's looking very fine actually. So this is our cantilever beam. So now let's go back to our plan view. So we have now finished creating our beams and our shear walls. So there are many functions or the many other properties that we can still explain about this beam. So, but I don't think we are going to be having that much time to do that. Okay, our call is going to be ending in 15 minutes. So, Engineer Henry, please, I would like you to drop the attendance on the chat box so that people can now start filling in their attendance while they are still on the call. So,
Okay, so what's the course code?
the course code for today is Prota Modeling 123. Prota Modeling 123. Did you get that? Okay, someone asked the question, can I please elaborate on the self-supporting walls? So I simply said that walls, our mid-pair walls or reinforced concrete walls are self-supporting members. They are not supported by any other members. Like for instance, we have your beams. Your beams are not self-supporting members. They are actually supported by your columns. Your columns are self-supporting members just like your walls. So your walls are not supported by any other member. It actually goes down to the foundation, just like your columns. So that is that. So now the next thing on our excuse me, okay. So the next thing on our
Mm,
agenda is our slab creation properties and slab types and slab openings. So let's go back to our ProtaStructure. So go to your modeling tab and to your reinforced concrete members section. You are going to find the slab icon here. Simply left click on it once to um have that. So when you click on that, what you're going to get is a warning which says your load cases must be defined before load assignment. What that simply means is that the load cases or the load combinations that you're going to be using for your modeling and your analysis of this building must be defined first before you now start placing your slab. So just click yes to get that. So you are going to get this load combination editor dialog. So simply click on add in order to add your load case combination. So your load case combination are simply your dead loads, live loads, partition loads, notional loads, seismic and horizontal loads if you are designing for buildings that are going to be subjected to earthquake loadings or that are going to be experiencing earthquakes. So you have to input your seismic values and then your wind loads and all that. So you have to impute that, but I would advise you to go to the loading generator to automatically generate that. So when you click on the loading generator, you are going to generate that from the um, building design code that you are now using. So there are different uh, different load cases that are provided. The values for these load cases are actually provided according to your building design codes. So are you following? So when you click on loading generator, you are going to get this
Engineer,
option. Yes.
I want to. I've dropped the attendance in the attendance form in
Okay, sir.
the chat box, so they can start filling it now.
Okay, sir. Thank you, sir. So our automatic loading editor, so we have the option that says create different combination for team members. So we are not designing for team members. Leave that unchecked. Use crack section in all vertical load combination as well. Leave that unchecked as well. So we have here your vertical loads and your horizontal loads and all that. I would advise you not to tamper with this. Do not reset anything or check or uncheck anything. So simply leave it as default and then say okay. So here, when you say okay, our loading combinations are going to appear here. So we have the combination one, G plus Q, which simply means your dead load plus live load, and then combination two, dead load plus pattern live load one, and then we have your notional loads on the direction of Y and X as well. So click on OK. So when you now click on OK, you are now going to have your slab properties dialog. So your slab properties dialog, you have the label, the slab types and all that. So click on the drop down arrow from on this type. So these slab types relates specifically to the table 3.14 in the BS 8110 design code. So the British Standard Code of Practice, there is a table there that is actually used to design slab based on the moment coefficient method, or the yield line method. So these types of slab from 1 to 12 relate specifically to that table. So where we have your continuous edges, okay, where we have your continuous edges and um, discontinuous edges and all that. So I would advise you to leave that as type 1 for all slab. So for every slab you are creating, leave it as type 1. So there is a function in ProtaStructure that automatically sets the correct slab type. So there is a function in ProtaStructure that automatically sets the correct slab type. So that happens when
Engineer,
you leave the, yes, sir.
I'm sorry for interrupting you. I'm sorry about that. There is an issue with the attendance. It's requesting for access.
Access.
Yeah, it's requesting for access. So the participant can't fill their attendance. Requesting for access. Okay. Well, I think we can resolve that in the next session now.
Yes, yes, before the next session, so that let's complete this.
Okay, we'll resolve that in
So,
the next
okay,
session. All right,
every participant, please listen. We are going to resolve that attendance in the next session. So, there's 28 of us here, 29 actually. So let's endeavor to be in the next session so that we can be able to fill your attendance. So this, I was saying that this slab type 1 to 12 relates specifically to a table 3.14 in the BS Code of Practice, BS 8110. So there is a function that automatically sets the slab type when you leave the slab type as one. So you also have the option of setting that manually, but I highly recommend that you leave it as type one so that you can have the correct slab type set. So here we have H. H simply means your the depth of slab. So um in the Eurocode Design Code of Practice, or the BS 8110 British Standard, so the minimum slab depth that we should have for our residential building is 120 millimeters. So you cannot go as low as 100 millimeters. But the traditional slab depth you will use in most of our residential buildings in Nigeria is 150 millimeters. So you also have the option to go as high as 175 millimeter depending on the use of your building. So if you are designing for a building that is going to be supporting for is going to be used for hotels, classrooms, hospitals, and all that, you can go as high as 175 on 200. So, but for now, let's say 150 millimeters. So here we have your concrete cover. So your concrete cover basically protects your reinforcement in the slab against different weather environment and all that. So here we have the self weight. The self weight of the slab is automatically calculated from the depth of the slab and the unit weight of concrete, which is 24. So the dead load on your slab, let's select the room, and then we have this dead load um, value here. Now the imposed load. So the imposed load is live load. So depending on what activity that's going to be going on in your building. So this is where you get the imposed load. So simply go to that place and then right click. So when you right click, you are going to find different use of building alongside their loading intensity values. So you have the general domestic use with the loading value to be 1.5 kilonewton per meter squared. So we also have hospital wards, we have residential communal areas, we have toilet areas, we have balconies, billiards, office areas above ground floors, we have classrooms, we have shopping areas, we have areas for parking cars and light vans, parking for medium vehicles and all that, plant rooms and all that. So I would choose to use 3.0 in the classroom. So I'm assuming that the building I'm designing is for classrooms. So let me just say classrooms, and then we are going to have the imposed load of that value 3.0 kilonewton per meter square. We have the option to input our roof loads, no load, and then your rain load as well. So let's leave that um, as default. Let's not input anything here. Slab does not contribute to floor diaphragm. Let's leave that unchecked as well. We are going to be explaining about diaphragm concept in our next training. So now to now start inserting your slab load, simply hover at a region where it's hosted by beam region. So insertion method beam region. So when you hover at a region that is bounded by beams, you are going to get this hash triangular um, lines. So simply click once to have your slab placed there. So our call is going to be ending in 5 minutes. So we are going to do this fast. So now continue placing that at regions where that are bounded by beams. Continue placing your different slab panels just like so. Let's place here as well. Place here. And place here as well. Place here. Place here. So there are many other methods of insertion of your slabs. So we have the axis insertion method, just an area that is bounded by axis. So just axis region so that I can insert slabs in my cantilever beam areas. So just like so, insert one here, insert one there. Just when you hover at this region, you're going to get that triangular, rectangular line and have it just like so. So when you have now successfully finished doing that, go to your 3D view to see what you have now successfully created. And you see now it's looking very exquisite. So now let's go back to our plan view. So now let's now model some cantilever slabs. So to model your cantilever slab, go to your slab icon, or let's take the properties of this slab. When you have now taken the properties, go to the slab type, go to slab type 12, that is your cantilever slab type. Now go to the cantilever, input the length of cantilever. Let's assume a length of cantilever of 1000 millimeters. So we have the I end and J end and parapet loading. You can add that if you want. So you have the D and B. So leave that as default. Don't input anything. Just simply input the length of cantilever. So your length of cantilever is simply um the length from the distance from the face of your beam to the face of your slab to the edge of the slab. So from the face of the beam to the edge of the slab and not the axis. So now we have now inserted our length of cantilever of 1000. So now simply go to the axis intersection, click that, click this column insertion point, and then click to this outer place. So we are going to have that just like so. Let's continue inserting that. So notice that our when we are inserting cantilever slab, so the slab are automatically going to be um joining to the adjacent slab. So you can see here it's automatically joining to the previous created adjacent slab. And you see that? Yeah. So that is exactly what we want. Now when we are finished doing that, say close. Now let's go to our 3D view. So this is basically what we have now successfully achieved. So in the next part two, in our next second what should I call it now? In our second phase, or in our second class this night, we're going to be talking about loading, building setups and all that. So that is that for this part one. So go to the group now. The link for the second class will now be dropped effective immediately. So thank you very much and God bless. See you in 2 minutes time.